Hi everyone, welcome back to a new lecture. This time we are still talking about knowledge graphs, but we are going to look at another layer of information that we need in those graphs and the corresponding standard, which is RDF schema. So before we go into the details, let's have a quick review of what we did so far. So first, you learned the idea of a knowledge graph, encoding knowledge about any kind of information in form of a graph with nodes and edges between them. So this is the example we looked at a few times before. We have information about a user called Bob. Bob is a friend of Alice. Bob is interested in the Mona Lisa. And we have more information about the painting, the Mona Lisa, who made it, movies about it, and so on. So we talked about in the first two lectures why knowledge graphs became useful. They're a nice, easy to understand and convenient representation of knowledge, especially for AI applications that need information about the world. When you ask your digital assistant about restaurants, about food, about movies, about cities to travel to, it has information about all of these entities. And nobody wants to sit there and type this all in, like in a long program. If question is Concordia, then print out Concordia in Montreal. This would never work. So you need to have this knowledge encoded in some machine-readable form. And after decades of research and development, this is the current state of the art for making this knowledge available to a system. We then looked at technical standards for working with this. So of course, there are different kinds of systems, databases, and so on. But for knowledge graphs, one of the major standards is the one that we looked at, the web standard based on RDF. Later, you'll see that you can work with different systems, export the graphs in different formats, but this is, since it's standardized, one of the most widely used ones. So the way to encode graphs using RDF is using triples. And what makes it a web standard is that all the positions in the triple, the subject, the property, and the object, are in form of URIs. We also talked about the serialization formats, so essentially the file formats, if you will, of writing these triples, and you've seen that there are a couple of different standards. So we looked at Turtle last time and N triples, and we'll see RDFA at the end as well today. So one example we've seen was the bookstore, where we integrated knowledge from different bookstores using RDF. So each book as an entity becomes a node in the graph. So here we give it a URL that includes the ISBN number. The book has a title, and in this case, it was the French bookstore with a link to the English version. And then when you serialize it, you can write this out like this. We have the subject, the property, the object, and then for the same subject, another property with another object. And you should remember that, this is the turtle notation. So to go a bit more in detail about these URIs, just to make sure everyone is on the same page and not getting confused about technical details. Let's talk again about URIs, URLs, and IRIs. So a URI is a way to identify a resource on the web. Resource can be anything, like a book we just had in the example, could be a person, could be Concordia University or anything else. It's important that a URI is not always a URL. A URL is a uniform resource locator. So something you can type into your web browser and get something back from a web server. For example, I could make up an ID for a slide by creating a URL like this. Sorry, a URI like this. So I'm saying that in Concordia, there is the lecture COM474. In there, we have lecture 3 and slide 5. So this would be a unique way of identifying a slide in our lecture. But now if you try to type this into your browser, you'll see this doesn't work. This is not a URL. You're not going to get any information back from the server. So this is an example for a URI that is not a URL. So it's important that these look similar, but these are two different things. And a bit later, in 2 weeks or so, we'll talk more about when you should make sure that a URI is also a URL. So the next point is, what is the syntax of a URI? Well, they can be quite complex, but in general, you have the information about the protocol, like HTTP or HTTPS, but could also be something else like FTP. You have the authority, so that's the domain name. Then you have a path, and then obviously you can have multiple subpaths like I had here. And then in the final path, you can also have a fragment. We've seen this a few times, yeah, Bob/me. Bob would be the page, basically the whole graph. And this here would be a fragment, like one node in the graph. And you can have more complex things in there, yeah. You can have these queries embedded and a few other technical details. But one of the most common confusions is that I've seen in the beginning between slash and hash fragments. So obviously you can have multiple slashes like here, but you cannot have multiple fragments. In most cases, you can think of them as sort of equivalent. You could replace Bob#me with Bob/me. There is again a technical difference when it comes to implementation, and for now, just don't worry about it. We'll talk about this a bit more when we come in a few weeks to some specific implementation details. But for now, just don't get confused about this. We've also seen namespaces, which you can use to shorten URIs. And just like in programming, you can use them to prevent name clashes. So you'll see in different RDF files and different vocabularies, you could have the same concept, but then you can distinguish it with the namespace. And then finally, as I also mentioned, the correct way of talking about it would be about IRIs and IRLs, which is just this internationalized form. You can have things like a French accent or a German umlaut in these URLs. That wasn't possible until a couple of years back when these were standardized. So technically correct would be to say IRIs, but just out of habit, many people still talk about URIs, URLs, because that's what's been around for a lot longer. So one benefit of using these knowledge graphs is that you can now integrate information from multiple sources. We've done this with the bookstore. So we took 2 different bookstores which had a relational database, exported them to RDF, and then you've seen that we could merge them because we had the identical URL here, and we could merge the 2 graphs. And this goes back to what I mentioned in the very first lecture. A common problem in industry and in science is that data has become compartmentalized. You have these silos of information. You have a database here, spreadsheets there, then you have email, then you have a development system, a bug ticket system, and you have source code repositories and what have you. So you have lots and lots of information, but they're all disconnected. And one of the things that you can do with the knowledge graph technology is to integrate these different knowledge sources. And very often in practice, this gives a huge benefit. We are just connecting 2 or 3 different information silos. Suddenly you can make new conclusions and get new value out of the data that you have. So this is very often an easy way for industry, for commercial or scientific application to get a step further in their analysis. So one of the ideas of this type of technology is that we want to get away from these isolated silos by merging data with each other. And then, as you've seen, we can make queries and further analysis on this merged graph. I also mentioned last time that this simple merging based on URIs still leaves open a few problems. For example, here we have a publisher. Here we have an author, and here we have an author. So the same thing, but one in English and one in French. And even when you stay in the same language, if you integrate different knowledge silos, they could name the same concept differently. So we have here English and French. You could have the same in German, but even in English, maybe in one knowledge base, somebody called it a book author or a writer or an editor, or there is a ghostwriter, a blogger, or a co-author. And you can see that, again, for an AI to connect all of this information is kind of difficult. So you want to know, do these mean the same thing? Or are there any other relations between them? Is one of them a super concept of the other? Now it turns out that this is something that people looked at for a long time. For example, in library science, people have classified publications, author titles, and so on for a long time. So one of these standards that you can find comes from the Library of Congress. And in there, you can look at information about authors and publishers. Maybe you'll just go to the live web page here. So if you want to check it out, loc.gov. In there, you can search for, example, authors and publishers. And then you find authors and publishers as a concept, and you can look at the different relationships that are in there. And you'll see that one way to access them is in different formats of RDF, like RDF XML, N-triples, JSON, and so on. So if you look at the RDF in N-triples format, then now you can see various concepts related to authors and publishers, and information like labels for human users, information like broader and narrower concepts, and then again, you can find the information about these concepts there. So this is an example of a specific type of vocabulary. In this case, it's a so-called thesaurus or SKOS. So it's a way to describe the structure, the semantics of your knowledge. Again, these are some of the triples that I just showed you on the web page. Just selected a few, like the concept. It has a label. It has broader and narrower concepts. And again, the details we'll talk about when we come to vocabularies down here. But this is one example of a structure that you can use to bridge these different types of information silos. So with this vocabulary, we can bridge different descriptions, different labels of authors, publishers, writers, and so on. And this way, we can glue these different information silos together. So this is one example of one specific vocabulary that we can use to connect and further describe the data that we have. And that's the topic that we are going to cover today. But before we start with the main part, RDF schema, two things to do. First, again, there is a worksheet. So now we're at worksheet number 2, and task number 1 is a simple refresher task. It's been a week since the last one. So just to remind you of the N-triples format and DBpedia, just do the first quick exercise. And then, like many of you have already done, post your result on the Moodle forum for worksheets, because we're having lots of fun discussions there. So the other thing, apart from doing this small exercise, have a look at this video on YouTube, which is Tim Berners-Lee talking about this new web standard. New as in new 2009. So remember, I told you that the idea of knowledge graphs goes back to early AI research, goes back to at least the 1960s, 70s, and so on. As a web standard, the first version came out late 1990s. And then again, it took a while before this became a major, widely used technology. So this was just at the beginning of this breakthrough of knowledge graphs on the web. First, if you don't know who Tim Berners-Lee is, please look him up. Otherwise, you have to give back your computer science license. And then have a look at this video to get a bit of an idea how things developed, what the idea was back then, and yeah, how it started out more than 10 years ago. And then I will see you back for the next part where we look into the technical details. See you then.